Good day, great talks, and welcome back to another lesson, boys and girls. I just did a video and I found out it wasn't recording, so y'all, let's just quickly carry on. So, boys and girls, we're looking at the parabola, and the parabola can be expressed in various ways. We have the y is equal to x bx plus c. This is known as your standard form. Y is equal to a bracket x plus p squared plus q, and this gives you your turning point. So hence it's known as the turning point form. And y is equal to a x minus x minus 1, x minus x minus 2. Okay, let me just quickly repeat that. Y is equal to a x minus x1 bracket x minus x2, and it's known as your x-intercept form. So boys and girls, this you should be familiar with from grade 11. Now I want us to quickly discuss the effect of a, since a pops up in each and every formula. So now boys and girls, a represents the shape of the graph. If a is positive, think of a positive person. A positive person is always smiling, so the graph will be giving you a smiley face. And if a is negative, a person that's negative is always frowning, so they'll give you a negative answer. Not a negative answer, a negative parabola. Now I want us to look at collectible marks, and these questions are what we would call collectible marks. Now boys and girls, the domain of a quadratic formula or quadratic function or parabola is the same as that of a straight line. X is an element of the reals, or x is an element of negative infinity to positive infinity. Now boys and girls, let's look at what we call the range. The range looks at your y values, the domain looks at your x values. So now the range. If our graph has a positive gradient, if our graph is smiling, if A is positive, you'll use this format. And this format is very easy, boys and girls. Y is an element of included q value to positive infinity, close bracket. And if it's frowning, whereby A is negative, y is an element of negative infinity, semicolon, q, and included bracket. Now, what's the value of q? If you can think back to last year, or to this year, because I'm recording this year when you're still in grade 11, but anyways, this is supposed to represent the y value. Q represents your y value of your turning point. But we'll get to it in case you don't remember. Now, boys and girls, I just quickly want to emphasize something, because I tend to see that people tend to think I'm a joke and I repeat things for stupidity or for the sake of, I don't know what, making a noise. Listen, determining the nature of roots is very important. It's a very important concept, because it could easily it could take you from a 70% to a 80%, from a 60 to a 70, from an 80 to a 90, from a 90 to a 100%. Now, I told you guys, learn that table that I gave to you when I was teaching number patterns and sequences, or sequences and series, okay? How do we do that? Or how do we deal, or when a question asks you to determine the nature of roots, how do you approach the question? Firstly, you get the parabola equation to be in standard form. And standard form, I mean ax squared plus bx plus c. Secondly, you would obtain the value of delta, otherwise known as the discriminant. And how do you obtain this? You obtain this. Freaking now! How do you obtain this? You obtain this by. How do you obtain this? You obtain this by saying delta is equal to b squared minus 4ac. So delta is equal to b squared minus 4ac. When delta is equal to b squared minus 4ac, you'd get a value, boys and girls. Now that value is supposed to lead you. Where is it supposed to lead you? It's supposed to lead you to that table that I gave you. And that table will describe the nature of roots for you. Now this question is usually a level 4 and a level 3 question. Okay. Now I just screamed because people were interrupting me, so I apologize again. Now, we have what we call the axis of symmetry. Now with the axis of symmetry, we can be asked 3 types of questions. Okay. The axis of symmetry refers to the x value of your turning point. Okay. Now the first type of question we could give you in the exam, you could be given an equation of a parabola in standard form. And when you're given the equation of a parabola in standard form, boys and girls, we could ask you to give us or determine the axis of symmetry. Now you then use the formula x is equal to negative b over 2a. Okay. And then, boys and girls, looking at the second type of question we could ask you with relation or in relation to the axis of symmetry, we could ask you to determine the equation of the parabola or determine the axis of symmetry, and meanwhile we've given you the turning point form or the equation, or we've given you the equation of the parabola in turning point form. How would you do that? How would you get that? You would get the equation of your axis of symmetry from your equation, from the form of equation given to you, and that you'd simply write as x is equal to negative p, and x would be equal to negative the p value, which is given to you in your turning point form. Secondly, we would be given, you can be given an equation of the parabola in standard point in x-intercept form, and they could ask you give us the axis of symmetry. Now, what would you do in such a case? You would add the x values of the x-intercepts and divide them by 2. Now that would be your x value, or that x value would be your axis of symmetry, or your equation of the axis of symmetry. Now, boys and girls, we're going to look at turning point. What is turning point? The turning point is whereby the graph of a parabola changes from a decreasing function to an increasing function, or from an increasing function to a decreasing function. Now, from the different types of questions we could ask you as examiners in the exam, or when writing tests. The first type of question I can give you, I can give you an equation in standard form, and I can ask you to give me the turning point. The formula you'd follow these steps. Firstly, you'd use the formula x is equal to negative b all over 2a. After obtaining that x value of the turning point, also known as the value of your what? The value of your axis of symmetry, you take that value, plug it back into the original formula that I gave you, and from there on, you'd find the y value of the turning point, and your turning point would be that y value, as well as the x value, that being the x value of your axis of symmetry. From there on, the second type of question I can give you is whereby I give you an equation in turning point form. So I'm giving you an equation in turning point form, right? The first thing you do, what would you do? What would be the first thing you do? You'd follow this step that I've given you. When I'm giving you an equation in turning point form, I am easily giving you the turning point. Turning point form, you already have your turning point. Why? Because the turning point is negative PQ. And when we look here at our equation, our turning point form equation, we have a P, we have a Q. We just have to make the P negative. That being said, in the third type of question I can give you the equation of the parabola in x-intercept form, and I can ask you to give me the turning point. What would you do in such a case? Step 1, you'd obtain the x value of your turning point using x1 plus x2 divided by 2. Then secondly, you take that value, which is also known as your what? Your axis of symmetry, and plug it in to your original formula that's given to you in what? It's given to you in x-intercept form, and you'd solve for y. That being said, now how do we sketch a graph? We sketch a graph by following the following instructions. Firstly, you determine the shape of the graph. If A is positive, we're increasing. If A is negative, if A is positive, boys and girls, forgive me, we are positive, so we are smiling. If A is negative, we're negative, so we're frowning. It's an upside down parabola. We then find your x-intercepts, And how do we find an x-intercept? Make y equal to 0. You find your y-intercept. How do you find a y-intercept? Make x equal to 0. Determine the turning point by going to learn the theory that I've given you in the beginning. Then from there on, you'd plot your points and sketch your graph. Now, boys and girls, let's usually just do this question and go over the memo that I made when I was still speaking to myself and not recording. Now, boys and girls, it says here we've given a parabola, we're given a function that's f of x is equal to 2x squared minus 2, and it says to us determine the equation or determine the coordinates of the y-intercept of the graph. The coordinates of the y-intercept. Y-intercept, you make x equal to 0. So we rewrote here. You rewrite your equation, substitute where you see an x, put a 0, you get your answer. Therefore, the y-intercept coordinates are 0, negative 2. Moving on to question 1.2, they ask you to find the x-intercept. You could easily use your quadratic formula, or you could remember your third laws of motion, which most people don't remember, and easily solve the question. So, to get your x-intercept, you make y equal to 0. That's a mark. From there on, you solve for x, and using your third form. But if you plug it into your quadratic formula, that's the safest bet you guys can get. Okay. That being said, we then move on to question 1.3. Question 1.3 asks us to determine the coordinates of the turning point. Now, boys and girls, to coordinates of a turning point, I remember, what am I given? I'm given my equation in standard form. So therefore, I'm supposed to use x is equal to negative b over 2a to find the x coordinate of my turning point, or otherwise known as your axis of symmetry. From there on, you take that in and plug it into the original equation of f of x, which is 2x squared minus 2, and you'd find the y value of your turning point. Okay, that's what I did. X is equal to negative b over 2a. We found that b was 0 and a was 2. We got x to be 0 as such. Then we plug in and we solve for f of 0, which gives us negative 2. So therefore the turning point is 0, negative 2. Question 1.4 asks us to plot. We plot our turning point, which is the same as what? The same as our y-intercept, as well as our x-intercepts. And when marking this, you get a mark for shape, a mark for your x-intercept, a mark for your y-intercept, and yes, if you don't put on your put in your turning point, you lose a mark. We'd subtract. Okay. Now, question 1.5 asks me to determine the range of f. Now, boys and girls, if you think back to the beginning of the lesson, I gave you a formula and I said, if we are smiling, your range will always be y as an element of included q semicolon positive infinity round bracket. So therefore, our q value, as we found when we're finding our turning point, because our q value is the same as the y value of our what? Of our turning point coordinates. Therefore y is equal to, y is an element of square bracket negative 2 all the way to positive infinity. And this is a good 1 mark. From there on, we're looking at question 1.6. Question 1.6 says, determine the value of a if this is a point on the graph of f of x. So if this is a point, we're already given the x-intercept. So they're essentially asking us, if x is equal to 2, if x is equal to 2, then what is the value of y, which is otherwise represented as a? And that being said, we would then say f of x is equal to 2x squared minus 2. Where we see an x, we plug in a 2. And that would give us f of x equals to 6. Therefore, our a value is 6. Now, thank you very much, boys and girls, for bearing with me and for going with me. I'm going to upload these notes. I'm going to also upload this if you see the video up, then the notes are definitely also uploaded. Learn your theory, boys and girls. Learn your theory, boys and girls. Learn your theory, boys and girls. After this video, there's another video that I'm gonna upload, which was already recording, discussing this. Watch it as a belief. Thank you very much, boys and girls. I truly do appreciate you watching, and I truly do appreciate you still sticking around, even though the crazy moments that I keep having this side. But anyways, yeah, all the best in the tricks, and keep working hard. God bless. Cheers.